identity is an equation that's always true. It doesn't matter what x you substitute in there. You're always going to get a true answer. So, for example, x plus 3 squared equals x squared plus 6x plus 9 is an identity. Now, why is it an identity? Because any x that you put in there is going to give you an answer. So, we can work on the right-hand side and show that it's equal to the left-hand side. So this is what we do is we can show that the right-hand side and left-hand side are equal. Okay, so the left-hand, this right-hand side, it's already in the form that we wanted. There's no, like, I have x squareds, I have x's, and I have constants. You can't add these to each other. This is the simplest form that we have. Now, the left-hand side, on the other hand, there's an operation to be done. So one thing we can do is we can just do the operation on the left-hand side and just show that it's equal to the right-hand side. So I say my left-hand side is x plus 3. I square it, and that means x plus 3 times x plus 3. And in order to find what this answer is, I just go ahead and I FOIL this. I say x times x, because that's the first term that I've got over here. So I say this x times this x gives me x squared, plus, then this x times 3 gives me 3x. Then plus, I'm done with the x's. I just did x times x plus, because this is a plus here, x times 3, which is 3x. Then I write the sign that I have here, which is a plus, and I multiply the 3's. I say 3 times x is 3x. I've got a plus there, so I put it here. 3 times 3 is 9. Now I have to add the like terms. So I look for x squareds. I say, do I have x squareds anywhere else? If I did, I'd have to add it to this x squared. But I don't, so I just have x squared. Then I say, okay, what x's do I have? Well, I have 3x's here, 3x's here, 3x plus 3x gives me 6x. And the number that I have is 9. And I look at this and I say, oh, look, my left-hand side is now equal to my right-hand side. I didn't even have to substitute anything for x. They're exactly equal to each other. So this is what's called an identity. Okay? Any questions? No?
No.
Okay, so when something is an identity, what are we saying? We're saying that the two sides are equal. Yes, but if we substitute any number in for x, we should get the same answer on both sides. That's what an identity means. It means that it works for all values of x. Any value that you substitute is going to work for it. So if I substitute any number in there, I'm going to get the right answer. Let's go ahead and substitute a couple of numbers so we can see this. Now, this is not a solution. This is just an observation, because we can't substitute every single number in the world in this. But just as an example, if I put x equals 0, then on the left-hand side, I get 0 plus 3 squared. 0 plus any number gives you that number, so this gives me 3 squared, and that's equal to 9. And then on the right-hand side, I get 0 squared plus 6 times 0 plus 9. Well, 0 squared, 0. It doesn't make a difference when you add it. 6 times 0 is also 0. plus 9, and that gives me 9. So if I substitute x equals 0, I get the right answer. Now, as another example, if I let like x equal 2 for the left-hand side, I get 2 plus 3 squared, because I substitute 2 for x over here. So I have 2 plus 3 squared, well, that's just 5. And 5 squared means 5 times 5, which gives me 25. Now, if I look at the right-hand side, I substitute 5 for all the x's. So here, I substitute 2 for all the x's. So I get 2 squared plus 6 times 2 plus 9. 2 squared means 2 times 2, that's 4, plus 6 times 2 is 12, plus 9. 4 plus 12 is 16. 16 plus 9 is 25. So again, I see that the left-hand side is equal to the right-hand side. And I can do this forever. I can continue substituting numbers in, and it's always going to be true.